Hi all, Dr. Clark here again. Forest management. For this lecture, we are going to discuss the log rules and scaling. So this lecture is going to be more about the logging industry, I guess you could say, or what happens to a log after it's been cut. There is some math involved. There's a couple different ways to uh, basically calculate how much a logger should get for a given log. Now, there are a ton of rules and there's a ton of information that goes into this. I'm not going to go in great detail about this. You can take courses on this. In fact, you could be, a scaler, which means that basically you grade logs that come into a log mill or maybe not even in the log mill, but maybe out at a logging site. You're grading the logs, you're measuring the logs, and you're calculating volume or board foot, and then you're providing basically a price. How much per board foot, or how much per volume of usable material, and that's the price that a logger or logging operation would get for that material. Of course, you would imagine that different species is going to give you a different rate, different quality of wood. There's lots of things that go into this. I'm not going to go into great detail about that because it's basically an entire course in itself. And it's an entire job in itself, and there's lots of rules and things like that. But I'm going to touch on it because I think a lot of students that are thinking about forest management, this is a piece that you don't really get, or you don't understand what it means to calculate a volume of a log, or scale, or the system of cutting trees and things like that. Okay, so let's kind of jump into it. The first thing I want to talk about is a measurement called the board foot. Now, the board foot is kind of a older measurement. It's still used in some societies, in some places. And I'd say the reason why a board foot is still used is because it's easier to calculate than, say, the volume. It's quicker, and it really, which method really depends on what is going to occur to the log. So what's the purpose of that log? So let's look at some general rules for board foot. First of all, logs are considered to be cylinders. Okay? And under the board foot rule, the measurement is derived from the smallest end. Okay, so basically you're considering it a uniform cylinder, and you're taking your measurement from the smallest end. Okay? So there's a lot of assumptions that go into board foot. Okay? It also assumes that all logs will be sawed into the same general thickness. Okay? Usually 1 inch is used, 1 inch boards. There's also a fixed procedure for sawing the logs. Now, this really will depend on the sawmill, whether it's a cut method called the through and through. Now, an older sawmill, or even a personal sawmill, a through and through is exactly what they're going to do. So if you want somebody to pay you board foot, and they're kind of a self-owned sawmill, they're going to do a through and through, and that's what they're going to pay for you. So that's a fixed procedure on sawing the logs, okay? And how much slabs they're going to leave, or material that's not uniform in size and may still maintain some bark on it. That's typically what a slab is. And in the case of a board foot, almost all sawmills that still use the board foot log rules, they're uniform. So the operation is uniform, the cutting is uniform, and there's really no deviation. So say you bring in ponderosa pine, and then you're cutting a region and you're cutting Doug fir, and then you're cutting a region and you're cutting red cedar. If you're taking that all to the same lumber yard and they're paying you based on a board foot log rule, the operation is the exact same. Okay? Even though another sawmill, a more advanced sawmill that might be using volume, would pay you different depending on the species, because different species are not treated as, everything's not treated as a cylinder with a volume log rule. We'll get to that in a second. So therefore, something like a red cedar, which might be much larger at the base than it is at, towards the top, that might give you a very different price than, say, something like a ponderosa pine, which again, a ponderosa pine is going to be larger at the base than the top, but it doesn't have that girth at the base that you would typically see in a true red cedar. All right, so let's jump into this. I'm going to go through some of the math so you can be able to calculate both methods, the board foot method and the volume log method. But we'll go through the math, and then if you need help, you can email me later, and I can help you with the mathematics on it. So this is the equation for the board foot. Okay, so number of board feet, and that is equal to the thickness times the width times the length divided by 12. Okay, it's pretty simple method to get to a board foot. Okay, so let's say we're dealing with a thickness of 1 inch. The width of the board is going to be 12 inches, or the width of the log is going to be 12 inches. The length of the log that in question is 12 feet. Okay, then you have 12 board feet. Okay, we can do it again. Let's say our thickness is changed. It's 2 inches. The width is changed. It's 8 inches, and now your length of your log is 24 feet. You're looking at 32 board feet. Okay. Now, to put this in perspective, most of you probably never heard of board feet, mainly because unless you're a contractor, or you have a history of forest management or logging in your family, board feet is probably not an average term that you've heard of. But there are places still today that's how you measure how much wood you're going to need for, say, a new house or a building or something like that. It's measured in board feet. Okay? And this way, it doesn't matter. This is, the board feet, however many board feet is needed, it takes into account boards that are 1 inch thick, 2 inches thick. Okay, so in general, it's just a method of charging for the lumber that's going to be needed to build a certain structure. Okay, and that would be charged maybe on board feet versus volume of wood. Okay, and volume of wood is often not used. Now, some contractors now, and a lot of them now, they'll just break it out. Like, instead of telling you board feet, they'll tell you, well, how many different types of woods, how many 1x2s are they going to use, how many 4x6s. They're just going to basically break out all the pieces for you. Okay, but when they initially might run a quote for a job, they might they might just leave it into board feet, because maybe they don't know the design yet, they don't know those kind of things, so they might just leave it in board feet. Okay, so let's look at kind of an example of that. About 2,000 board feet is needed for a 3-bedroom home. Okay? And so this is obviously increasing as time goes on, because 3-bedroom homes in the 80s are much smaller than 3-bedroom homes in the 90s, and 3-bedroom homes in the 90s are smaller than 3-bedroom homes that are built in 2020. Homes are getting bigger. You might not be adding more rooms, but we're adding more space to the home. Okay. Some cases that increases the amount of board feet. Okay. In other cases, maybe the board feet doesn't change too much. It's just the distance or the area around is a little bit different. But in general, board feet are going up with the year, or as time goes on, board feet is going up. So let's talk a little bit about a logger. So we're talking about the profession of logging. Okay, so a cutter, or a sawman, it depends on what you want to call them. They're called lots of things: loggers, cutters, sawmen, axemen. Although very few are cutting anything down with an axe, but they're called lots of things. But a cutter on average will make about $15 per 1,000 board feet. Okay? Now this is profit to the individual. $15 per 1,000 board feet. If you take, 20,000 divided by 1,000, you got 20 times 15 is about $300. Okay, so the average logger to cut the amount of wood needed for one 3-bedroom house makes about $300. Okay. You might say, holy crap, that's not a lot of money. And it's true. It's not a very big chunk of money. Now, can you make more? Of course. If you're not cutting cheap lumber for houses, and you're cutting more expensive trees and things like that, you might be paid a lot more per 1,000 board foot. Okay? But most individuals are cutting for the purpose of either home building or something along those lines. Okay, so about $300 is what they'd make on an average home. Now, there's more to this. So maybe they're actually making more than $15 per 1,000 board foot. So if you're looking to be a cutter or something like that, maybe they tell you make $45 per 1,000 board foot. Okay. But often what the hidden cost is unless you're going to do everything yourself, which very few cutters is going to do, because it would turn this 20,000 board feet into a very long time, a much longer time if you're going to do it all by yourself. So often a cutter will hire individuals, okay, and maybe a couple individuals to be chokers or choker setters. Okay, and I'll show you what I'm talking about when I'm talking about chokers. Also has to hire their transportation. Sometimes they're hiring sometimes they're hiring a logging truck operator, okay, out of their profit. Other times maybe that logging truck operator is paid by the haul from a different source. Obviously the cutter's paying for their saw equipment, paying for their chains, their gas, oil, those kind of things. Also paying for their insurance. This is a big one. Logging is not a job or occupation that you want to skimp on the insurance. Okay. It's a very dangerous job. And so insurance can be fairly expensive. And that's coming out of their pocket, because most loggers, even if you're working kind of as a contractor through a company, you're an independent contractor. So you're basically hired to do a job. You're paid by the board foot or the volume or some some amount. Maybe it's by number of trees cut. There's lots of other ways to pay cutters, but nonetheless, often you're an independent contractor. That's your job. You're contracted to do certain jobs. Even if you work for a corporation, you're still contracted out. So people will ask, well, why do it if you're making around $300 a day, maybe? Okay, and maybe you can't even do $300 a day because maybe you can't do the 20,000 board foot in one day because of the terrain, or maybe it's a 2.5 hour drive to your site, and you can only cut for so long, and whatnot. So there's lots of possibilities that you're not even making $300 a day. Now, some loggers make more than that. I'm not. It's just kind of on average, just giving you a ballpark. So why do it? One of the key things is you don't need any education. You graduate high school. You don't even have to graduate high school. Okay? You can just get hired on and have a saw of your own, have the equipment of your own, negotiate some kind of contract, and start cutting. Now, are there schools for cutters and log work or sawmen? Absolutely. There's lots of schools, and it's highly suggested that you would go to them. And in some corporations, they're paying for you to go to these. Some corporations just suggest that you go to these. It just depends. There's lots of situations where individuals are, again, you're your own contractor, so you just contract what's needed. And, as far as like insurance and things like that go, that's up to the individual, okay, because you're an independent contractor. All right, let's look at the cubic volume. Okay, so the Semlan cubic volume is a little bit different. It's a little bit harder to calculate. Mainly when I say harder to calculate, it's not because the math is hard. Okay, the math is fairly easy. It's just calculating the volume. But what's going on is now, instead of going through and just taking a single measurement or two measurements, the length and the width of, the smallest end, now you're taking the length, the radius of the small end and the large end. So you have a little bit more work, and then you have a little bit more math that, a lot of individuals are not going to be able to just crank out in their head. So it's a little more involved. Now, there are specialized calculators that do this, and there's specialized calculators that tell you a lot of other things, other ways to calculate the volume of a tree, the useful portion of the tree, etc. Even in some cases, well, there's lots of calculators that will even tell you how many 2x4s can you get out of that tree. Okay, there's different ways to calculate things, and it depends on the industry and depends on who's doing the measurements, what they're after. Okay, but let's look at this cubic volume kind of setup. So first of all, V is equal to volume in cubic feet. Okay, so big A is the large end cross section area, feet squared. Now you see that this says big A also. That's because autocorrect. I'm sorry about that. This should be small a. The small end cross section area is feet, is small a, sorry. And it's the area, so it's feet squared. And then you're taking that and you're timesing it by the length of the log in feet. Okay. So let's look at an example of this. Let's say you have a log, its length is 36 feet. The large end's radius is 1.5 feet, and the small end's radius is 0.75 feet. Okay. So if we look at the area of the large end, it's just a simple area of a circle or a cylinder. So you're just taking 1.5, you're squaring that. Okay, that's the radius squared. You're timesing it by pi, or 3.14. Okay, and that'll give you your big A. Area of the small end is 0.75 squared times 3.14. That's your small a, or the small end. Okay, and then you can calculate the cubic volume by taking big A times small a divided by 2, times it by the length. And now we're saying that a log with these measurements is going to have about 224.5 feet cubed volume. Okay, now that's important. That's important for a lot of things. Let's say we're talking about lumber. Now you know how much lumber you have, and in many cases, the measurement of the radius will be from the center to the edge of the bark. So it won't go out to the outer edge, but the inner edge of the bark, because the bark is going to be removed. Okay? And so how it's measured really depends on what's the purpose. Because if we're talking about maybe something like pulpwood, so maybe you have some poplar or something like that, and you're going to just turn it into paper, and that bark might not even be removed. That bark might just be ground up along with the pulpwood, and turned into paper. It depends on the paper source and the process. Okay, so for some things, a volume of 224 feet and a half is a great measurement. It tells you exactly how much wood you have in cubic volume. And so from that, you can calculate, well, how much paper can we get? How many cardboard boxes can we get? How much, whatever it might be. The other piece is, if you know how much waste wood you would have per log from this volume, so maybe you know the cubic volume of waste. Okay, so maybe you have to leave a ½ inch between each board. Okay, depending on the type of wood, maybe the bark is a certain thickness, so you have to remove that volume of the bark. These things can all be subtracted from this cubic volume, and then you can figure out, well, how many 2x4s can you get from this? How many 4x6s, or whatever it might be, whatever the calculation might be. All right, so I talked about individuals, cutters, paying for their choker, and I think a lot of individuals that may not be familiar with logging in general, someone saying, oh, you're paying for a choker, and that's someone that does a job, you might not know what that means. Okay. So this is a fairly, I guess, typical setup when it comes to logging. You would have kind of a platform, which you have a yarder sitting on, okay, kind of a tower, series of pulleys, okay, that are going to drag logs up onto the platform. Then they can be loaded onto a truck and taken away. Well, in order for those logs to be drug up the hill or chained up and drug through the air, sometimes these haulback lines are much higher in the air. So these logs actually get lifted, and they're lifted across the canyon or something like that. Depends on how deep this reservoir or this area is, on how it's drug up the line. But regardless of that, okay, off of that haulback line, you're going to have what we call a choker. And this choker is a cable that is wrapped around the log, the individual log. Okay, sometimes you might have a couple logs on a choker line. It depends, again, on the strength of the yarder, the size of the logs. There's lots of things that, the steepness of the hill, how far it's got to be hauled up, okay, how many chokers you would have off a line. These chokers, though, they're wrapped around the log themselves, and then the logs can be drawn up. So a cutter would cut the logs, okay, in a region. Choker would come in, hook onto the logs, okay, and they'd be run up the line, and they'd be loaded on a truck, etc. Depending on the job of the cutter might be off in the distance, cutting more. So then the yarder can be moved over to do that. The other thing is, the cutter could be running the yarder, or maybe running the piece of equipment that's loading the logs. There's lots of ways at which these operations can go. Okay, But again, a choker is the individual that sets what we call a choker line or sets the choker. Okay. This job is super dangerous. It's I don't know if you watch those shows of Most Dangerous Jobs, but it's been on Most Dangerous Jobs. A choker is a very um, physically demanding job. First of all, you can see these three individuals. They're running choker lines. So basically, logs are ready to be hauled up. Okay, so they grab the cables, they run down the hill, they hook it up. The faster you can go, the better, because obviously time is money. They hook it up, they get out of the way, the logs are hauled up, and then they go up after it and run the lines back down. This is a very energy demanding, physically demanding job. And for the most part, that's why you see young men doing this job. Okay? Chokers, I mean, I don't know what they're paid now, but, back in the day, they were paid, maybe $10 an hour. Okay? Maybe it's a little more now. It depends on the type of log and the logging situation. They're not paid very much, but their job is extremely energetically demanding. You don't want your cutter to be doing the choking also, because cutting itself can be very energetically demanding, and I don't want to say it's a waste of time, but to have a cutter do his own cutting and his own choking, it takes forever. Okay, so you can see here, this is just kind of the choker, sometimes what's called the choker run, which is basically grab the cable and go down the hill, hook it up, and then start hoofing it back up to grab the cable, run down the hill, hook it up. Okay. Now, we talked about at the beginning scaling. We talked about kind of the process around scaling. It's a very ancient, old process of finding out board feet or volume. And not just that, part of the scaling job is to grade the tree, to grade the lumber, grade the material. If there's big winter cracks and things like that, you need to note these and estimate the depth of these, because the ends need to be cut, so you're going to get less board feet or volume, because they need to be squared off and the cracks need to be dealt with. Lots of things go into this. I'll talk about some of the things in a second, but so you'd have what's called a scaling tool, or sometimes called a scaling stick. Okay, there's lots of different ways. The newer ones are, made out of plastic, because everything is. But anyhow, you're taking a measurement, depending on if you're going to be calculating board feet. Maybe you're just taking a measurement of the smaller end and then a length. You're grading the log. The length of the log can be difficult. It depends on how much warpage the log has. You have to account for that in many cases. So there's lots of situations that go into this. There's lots of codes that are written, painted on to the logs, that tells basically the guy who's cutting the logs, what's going on with this log. And so you can see this individual is painting or marking. This individual is running a specialized calculator that calculates board feet or volume or some calculation after she has already measured some of the boards. Okay, there is a National Forest Log Scaling Handbook. Okay, and it's pretty, I don't want to say it's dense, but it's got a lot of rules into how you go about determining the length of a log, how do you determine the radius, and these kind of things with different situations. So if you have, a convex, concave shape, or maybe you have a warpage in multiple ways, where are you taking those measurements from? Okay, if the ends aren't level, if you still have the wedge marks on it, okay, where are you measuring from? Okay, it needs to be trimmed off. If it's cut at an angle, it needs to be shortened. There's lots of rules and regulations basically stating, how are you going to measure the length of the log, and along with that, radius and things like that. And then also many things go into context of this, like the quality of the log and things like that. That would be in the log scaling handbook. Okay, I'm not going to cover these because, like I said before, log scaling, it's an art of its own. I don't know it very well. I know, some general things about it, but there are schools that teach log scaling still today. So let's say you've already got your diameter, you got your volume, you got your length and everything like that, and you're ready to go. So what happens to the log? Well, now it's determined by the mill, and often by the mill type, on what kind of saw method or sawn method are they going to use. Okay, so a plane saw would be something, that looks like this, where you're cutting it on different horizons, and it's not a clean through and through cut, and you're getting a couple different size lumbers, mainly the same depth, but often, you might have a centerpiece where you're getting a big piece of timber out of the center. Okay? You have the quarter sawn, which often tries to utilize as much of the wood as possible. You get a lot, maybe it's all cut at the exact same depth, but you might have lots of different widths that go into this. And then the through and through cut. The through and through cut by far is the easiest cutting method. The through and through cut is often done by what I don't want to call them do-it-yourselfers. This is the old method. This is the method that you would do with a handsaw. This is the method that's done with personal sawmills often, mainly because you're not twisting, you're not moving the log ever. Because most people that are going to do a personal like sawmill, they don't have the equipment to be twisting the log around. The logs are heavy and you don't have that equipment to move the log. These other methods are much more advanced methods, typically used in sawmills that have rotating devices and maybe multiple saw blades going in multiple directions to do different types of cuts. Okay, and so that kind of brings me to what I'm talking about here. So a through and through, this might be a sawmill where you're doing a through and through cut. You can see here they have a long, basically it's like a bandsaw, and so it might have a long saw blade. It comes in, you set the depth. So in this case, you're cutting off the slab first, trying to get it to where it's even. Okay, and then you cut that slab off. Then you might rotate the log, cut the slab off. Rotate the log, cut the slab off, and then you have a square piece of wood that you can just cut in your certain depths. That happens quite often in kind of personalized sawmills. I'm not saying this is a personalized sawmill. I'm just saying that's a method that's often done in that. Some of the other methods, with the invention of more high-tech technology and things like that, we have lasers now that guide saw blades, and we have rotating devices that are in our sawmills. So you might have many different ways to cut the log now that one of those other sawmills just can't do it because there's not enough manpower and there's not enough strength in the system. So the logs like this might be cut in many different ways through the use of lasers, and that's probably the sawmills that are cutting your lumber today are probably using this method. Unless you're paying high end lumber costs, then maybe they're cut in a facility like this, where an individual might be running the whole system from behind a screen with kind of a joystick to move claws and things to move logs on, etc. It's all digitized. Again, it's lasers and computer. You can see the lasers here. It's all computer generated. It cuts everything. It's utilized so the least amount of waste is occurring, okay, and the most uniform pieces of wood are coming out. That's important for the logging industry of today, because we're not just cutting down every forest that we see. We're planning and managing those forests for the future. So there are forests in the future. And by doing so, you also have to upgrade your facilities and basically realize that the less waste you have, the more product you have, and the more profit you have. Now, facilities like this are very, very expensive, but again, some of that decrease in waste adds to profit and eventually could pay off this facility fairly quickly. It really just depends on what the facility is about. Is it high end lumber? Is it, are we talking about really cheap lumber, certain species? There's lots of different situations of why these facilities would be advantageous, and situations where they're just not going to work. You're not getting enough profit out of the lumber itself. Okay. All right. So with that, next time we'll talk a little bit more about some other types of equipment that are not based necessarily on logging, but are based on maybe research or based on management. And that's what we'll bring in to talk next time.